Cool. Thanks for sticking around. I know this probably not the talk you were expecting to see at this time and in this spot, but thank you for sticking around and hearing what I've got to say. So today I'm going to be talking to you about how the LEGO group utilizes the power of step functions to process loyalty orders. So first off, let's talk about who this random guy is stood in front of you, waffling at you. So 3 main things you need to know about me. I am what you call an energy drink fiend. It's a very rare occasion you see me without some sort of energy beverage in my hand. I am a self-confessed tech head. Anything in the tech space I love to get involved with. My recent one has been gaming consoles, Steam Decks, ROG Allies, if anyone out there is also into that sort of stuff, hit me up. I'm also an AWS community builder, so I was lucky enough to be chosen to be part of the program earlier this year. And it's been a great experience so far. Would definitely recommend having a look at it online and gaining some more info if you haven't heard about it before. So on the agenda, we'll run through quite a few different bits and pieces. So we'll talk about what loyalty is at LEGO and the LEGO group. We'll talk about what a loyalty order is, as opposed to an order, let's say. We'll have a look at the order processing flow that we have. We'll have a look at AWS step functions. Then we'll talk about how we do it within the loyalty squad and on the loyalty service platform. Then we'll look at how we're handling updates and do some talking about next steps and where we're going to go in the future. So, the loyalty program. Has anyone here been on the LEGO website or been into a LEGO store? Hands up, yes. Cool, might have, yeah. Has anyone signed up for any VIP programs, or now it's known as LEGO Insider? Cool, so anytime you've been into a LEGO store and bought something and used your VIP or loyalty membership, that would have then flowed through our services. So the loyalty squad sits under what's called the Marketing Channels Technology Department within the LEGO group, which also sits under the larger sort of digital department within the LEGO group. And we sort of look after sort of 3 main areas. So Lego.com, we all know and love and have all spent hours on there browsing, looking at the next sets that we want. The retail store operations, again, somewhere we've all been in and looked longingly at that new T-Rex set. And the customer support centers, so the places that you can call up or get on live chat with if you ever have any issues or anything like that. So the loyalty service platform itself has sort of 4 key areas and 4 key parts. So you've got the LEGO customer, so anyone that's sort of visiting the LEGO retail stores or shopping at Lego.com, anyone who joins the loyalty membership or becomes a LEGO insider. And once you've joined that membership, you can then earn the loyalty points. So then you can actually use that to redeem against rewards, whether it be like vouchers or special stuff from the online store. And you've also got your in-store experiences that you can also use the points on. And we must be doing something right because we are actually technically award-winning. We've been finalists in a couple of things, so the customer analytics, insights, and metrics, and the offer incentive and reward design. And we got a platinum award and a gold in 360-degree brand. So we must be doing something right if we're tending to pick up these awards and getting good feedback. So let's now have a look at the actual service platform overview. So we've got the loyalty customer. They wander into a LEGO store, have a browse, pick up what they want, go up to the store till, and once they've like placed their order, if they've added rewards or not, this will flow through to the loyalty API. And then there's 2 things that can happen. So if they're an existing insider, that will then look at the rewards. If they need to earn points, or if it's like a return order or something like that, and points need to be reallocated back to them, that'll happen. And then the order is technically placed. On the other side of that, if it's a new insider, then there's no rewards that they're going to be dealing with, so then that just goes straight to the order being placed. We also have some external applications that we talk to, some sort of third-party CRMs and things like that we have to reach out to. We've also got traffic and sort of communications with Lego.com, and the other loyalty services as well will all talk and all feedback into that loyalty API. So this is what we call the loyalty service bounded context, and these are the microservices that live within it. So these aren't all of them, but these are a good chunk of them. So we can see that we've got things like orders service, so we've got a members service, and we've got, like, on the sort of far end, we can see that we've got these sort of anti-corruption layers that will reach out to external places and sort of act as a sort of barrier and a gateway to feedback to the rest of the services. So you'll notice that some of them are highlighted, and those are the ones we're going to really focus on today. So you might be thinking, okay, what's a loyalty order and how is it different to a normal order? So let's have a look. So a loyalty order for an insider needs to be someone that was signed up to the insider program and is verified. It can either be in-store or online. It can be a sale or a return, and it's going to have rewards on it, which could be either vouchers, instant redemptions, and things like that. So if we look now at the actual order overview for this insider customer, so they come into the store, they place their order, that runs into the loyalty API, and then we've got our order service that will pick that up, and that order service will then start processing that and emit an event. That event will then get picked up by the CRM service that we have, and then that CRM service reaches out to the CRM, says, look, got this for you. CRM will go, okay, cool, I'll do my thing, I'll update, and then it comes back to the order service and the process is completed. So there's the capability to handle both sale orders and return orders. So if we have a look at a sale order first, so on the sale order, you'll have things like your order item details, so we can like work out the quantity, how many of this sort of set that they might be buying. We obviously get the SKU, which is the product ID, so we know which product it is when we're handling it. The price, obviously that's needed to work out things like how many points they might earn. The order total, again, all factors into the points that they earn, and obviously earning points. And rewards as well, so if there's any sort of thing that needs to be considered when looking at the rewards in terms of how the points are earned or if points are being spent. So if we look at the sale order processing overview, so we're receiving that order payload into that loyalty service API, and we have a Lambda function that performs checks on that incoming payload, and then that emits an event. And then the order service picks up that event and starts its processing. So you'll start off by storing the sale in the storage first pattern that we have in the loyalty squad. It will do things like check the insider status, make sure that they're signed up and that they're verified, and do a bunch of other things that we need to do before we can continue processing. And then it will look at reward redemption when looking at the context of a sale order. So if there's any actual vouchers being redeemed against the price of it, so it might be a reduction in the price or things like that. And then that will go on to that CRM service, and then the CRM service talks to the CRM, and then that comes back, and we get the order placed. So that's the sale, and now we look at the return. So return item, again, you're going to have specific details on there, so we need the quantity, the SKU, which is the product ID, so then we can sort of figure out, okay, which product is being returned, how many is being returned. Then we'll also look for the sale number, so then we'll be able to match up this return to a previous sale, so we can check that the things that are being returned actually line up correctly. So again, they need to be signed up and verified if it's an insider doing the return. And then we can also reallocate points, so if they're returning an item and they might use points, we can then reallocate these back on so they're not losing out. So if we now check the return order processing overview, so again, we start off with the incoming request to the API. We've got the Lambda function that's performing the checks and emitting the event. We've got the order service that spins up and it starts checking the processing. It stores the return this time, again with that storage first pattern. It finds the original order number, does the other bits and pieces that we need for processing to make sure we can carry on. And this time, with it being a return, we actually then look at reward reallocation instead of redemption as we did for the sale. So we can then line up the customer account and make sure that all their points and everything like that matches up. And then it follows that same pattern of reaching out to the service, the CRM service, which reaches out to the CRM and then gets its response, and then we go on and get the order being placed. So you'll notice that the key sort of area of difference between a sale and a return is sort of this section that's highlighted. So where we've got the actual difference is in looking for the original order number, for example, when looking at a return, and we've got the reallocation when looking at handling the rewards. Otherwise, it's a very similar flow, as you can see here. So we get the insider customer, the Lego store, you've got your till with the rewards that you can select at the till, goes to the API, goes to the order service, and that's where your rewards are applied. So either your redemption or your reallocation, and then we have a successful order placement. Now, you might be sitting there thinking, this is all a bit complex, isn't it, for an order process? Can I not just go in and pay at the till and that's the job done? Yeah, you can for you, but complexity, as it was said in a talk earlier, the complexity is always there, it's just now on the surface. So we can actually see it and deal with it with things like sessions. So what we do, we have the incoming request coming into the loyalty API, and then we have a session service. Now this will use sort of three main things. So we've got a loyalty reference, a merchant reference, and an order reference. And all of these will be unique, and all of these will be unique to this session. And then what happens is this will get generated within the session service, and then an event will be emitted from there. So if we go through this order processing flow now in terms of AWS resources and how it actually flows from the things we use under the hood, we can see that we've got the API gateway that calls into the Lambda. And this is quite important to note that we have a synchronous response that goes back to the API gateway, because if you think about the actual context of placing the order in a store, you've got an actual customer stood in front of someone in store behind a till, and you don't want them waiting there whilst we're performing all our checks and doing what we need to do behind the scenes. So we send them like a message saying, yep, all good, or we might say, no, payload's not quite right. So then once that order's validated, we send out the event, and that customer order event will go to the order service where we'll run things like step functions, Lambda functions. We'll use DynamoDB to store things. We'll use EventBridge. And we also use these things called task tokens. Has anyone worked with task tokens before or heard about them? A couple of nods. So task tokens are a really powerful thing, or have been a really powerful thing for us when working with handling the order processing. So basically what happens is we attach this task token to an event that we're able to send out. And once we send out this task token whilst we're processing in the order step function, it pauses that actual run of the step function until it gets a response back as to like the status of that task token. So what happens with our task token in this instance, it goes through to the CRM service, and the CRM service will reach out to the CRM based on the response from the CRM. If it's a success response or a failure response, then that will determine the sort of status of the task token that gets fed back to the order service. So then the order service will know, okay, cool, so this is a success, I can carry on processing. Or, oops, something went wrong somewhere, going to need to throw an error in the step function and have the error handling pick that up at the end. And then once the order's processed and everything's good, we fire off an event for the rest of our services to pick up and have a look at. So you'll notice that we use quite a few different resources across the sort of AWS spectrum. of products. And that's because different services require different resources. We don't want to box ourselves into just using one resource across all our services. It's always best to pick the resource that's going to work best for the service that you're building and the problem that you're trying to solve. And it's also worth thinking about the architectural considerations around how to achieve like the correct processing flow, for example. So would these fit in architecturally with what we need to achieve and how we need to achieve it? So let's just do a quick summary of the requirements that we have within the loyalty squad for our order handling. So we need to be able to communicate between our various different services so we can handle the various different parts of the flows that we've seen. We need to handle interacting with multiple resource types, so different types of resources between different services as well. And we need to be able to handle synchronous as well as asynchronous actions, because we've got the customer install waiting for that response, which is our synchronous, and then we have our asynchronous processing that goes on after that has been returned to the client. So AWS step functions, hands up if you've played with them, tried them, like them, hate them. I've seen a few hands go up. That's cool. I personally love them, and I'm sure my team and squad mates are sick of me going on about them, but I'll do a quick reminder on here. So AWS Step Functions is a managed workflow service provided by AWS. It's got built-in error handling. Has recently come out with some updates to that error handling, which has been really cool to see, and I'm really keen to get stuck into even more. You've got built-in state management, so you can put in your input at the top of the step function, and it'll be accessible all through the execution. And you can get real-time and auditable workflow execution history, so you'll actually be able to go into your AWS console and see each and every actual execution that's happened. Really good if you're trying to track down an error and you want to look through and see the execution where that error was handled. So there's also a thing called Workflow Studio. Now, if you haven't tried AWS Step Functions before, I would recommend this being your first sort of port of call. If you're going to go and have a play around with it, go play in the Workflow Studio. It's just a nice, simple drag and drop interface where you can create a step function with various integrations and just get a feel for how it sort of works. So with that, you've got a couple of different workflow types with step functions. So you've got your standard workflow type, which is the one that most people are familiar with. So this is ideal for sort of longer running workflows, which can run for up to a year. You can have like wait states that'll sort of hit. You can have that put in there. You can say, wait for X amount of time, and then after that, let's carry on. And you can get full execution history for up to 90 days, which is really handy. So you can have that auditable log that you can always check through. And it's billed by state transition, not duration. So it's not like you're going to pay, like if you've got one that's doing that run for up to a year, you're not paying for that, like for the fact that it's running for a year. You're paying for how many times it goes from step A to step B to step C. So it's really cool that way. So you can have that long-running workflow and not have to worry about, oh God, it's going to cost me an arm and a leg because it might be running for up to a year. And then on the other side, you've got the express workflow, which is ideal for high-volume event processing workflows. And this one is more geared towards your shorter execution times. So this one can only run for up to 5 minutes. And that's billed by number of executions, duration of execution, and the memory consumed. So that's more in line with some other sort of AWS services. So 2 different workflow types. Each has their own benefits, and each has something that might not fit with what you might need them for. And they can integrate with all the things. So you've got 220 and counting AWS services that they can integrate with, probably much, much more at this point. And the integrations run directly in the actual execution. You're not having to write code to actually then get them to run themselves. So it can actually remove that integration code. So whereas before you might need to write a specific handler that might go and fetch something to actually set up like an integration with DynamoDB, you can actually just say, step function, go talk to DynamoDB, and it will do that for you basically. And it's got familiar syntax as well, so if you are in the console and you're wanting to do like a DynamoDB get or something like that, it's very familiar syntax and the same sort of syntax that you would use normally anyway. And you compare it with what's called AWS states language. So within the actual steps, you can use the states language to do things like generate UUIDs or do simple sort of joins and stuff like that with strings. And there's quite a bit more to it. There's some good documentation on the AWS website for that. So I mentioned Workflow Studio earlier. This is a screenshot of that UI. So it's a low-code environment, visual workflow editor with a nice drag and drop interface. And what it does, it actually auto-generates your code for you as well. So you could actually just copy and paste this code into your editor and carry on working if that's what you wanted to do. And you can easily review and export that generated code before you actually take it away, because you get a little nice preview window with it in. And you can export as JSON or YAML depending on what your preferred flavor is. So I've waffled on now about my favorite subject being step functions. So how do we do it within the loyalty squad? So I'm going to ask you to brace yourselves at the minute for this next sort of image that's going to appear. This beast that you see before you is the actual order processing step function that we currently have within the loyalty squad. Looks quite scary. Yes? No? Don't want to look at it anymore? No, neither do I. So I mentioned a few times that we run a storage first pattern. So what I'm going to do is I'm going to sort of go through the key points of that step function. I'm not going to run through it all because we don't want to be here until next year. So the first thing that we'll do within this step function is we will store the order in DynamoDB. So we'll store the full raw order, we'll log the unique references, and we'll take note of the execution name of the step function, so of the step function execution, so we can go back, look through our logs, and then find it if we need to, if there's any errors or anything like that. It will also run a few checks on the payload data, things like that, and obviously if it detects any errors, it'll then send it through down to the error handler. And it sort of forms the starting point of our observability for the insider order process as well once it's running through here. So I also mentioned earlier about task tokens, so a bit more on those. So like I said before, we've got this event that gets added to the event bus with that task token on, so we can see on this dispatch sale here, you can see that little line trailing off as well, which can handle anything that goes wrong. And we've got the fact that the step function execution pauses until the response is received, which is really handy because you don't end up with a bunch of unnecessary failures or incorrect past responses if you, for example, not waiting around for that. So we have 3 different response types. We've got success, error, or retry. So obviously success, all good, carry on going through. Error, something went wrong, throw it down to the error handler, or retry, where it can then retry the order and try again. And what the task token really allows us to do is keep our microservices really decoupled, and they'll be able to react when needed. So if we didn't have this task token use in here, we'd have had to put this sort of functionality where it's going to reach out to the CRM and wait for its response in this orders microservice, which doesn't make sense really to have that because it's not strictly related to the order. It's reaching out and doing something CRM related. So having this task token there allows us to have this separation and proper decoupling. And the task token handler itself is even in a separate service, so you can just see how it allows you to say properly decoupled and say really concise with the microservices that you do have. So obviously we use a catch for the actual error handling. So we can actually see the task token journey and what it allows us to do. So order service, you can send out your customer order or customer rewards, events, and then goes through to that CRM service. It'll reach out to the CRM. Yes, no, maybe, as a like retry. comes back with the response status, and then that feeds back into the orders service. So that's essentially what this task token is doing in a nutshell. It's going off and doing this check for us before carrying on with that. Another thing that we're able to do within the step function that is really great is we can act in parallel. So what we have here is we've got this orders service that can run these three things at the same time. So we've got the release, the redeem, and the reallocate that's handled when looking at the rewards that we may have on the order. So rather than having to check, okay, release, wait for that to finish, and then check redeem, wait for that to finish, then go on to reallocate, which would take up quite a lot of time, we can actually run these all in parallel, run them at the same time, because we've got this decoupled architecture using these task tokens, and then they can all feed straight back into the orders service, and we can carry on, and it just makes our life so much easier. It makes things much, much quicker as well. And I've said the word, or the three letters CRM quite a lot so far during this talk, and you might be wondering, why bother having that separate service for the CRM? Just chuck it where it's needed, and that's fine, surely. You can get away with that. But this CRM service acts as what's called an anti-corruption layer, so it's not, it keeps it separate, so it keeps it away from the orders service or the members service, because they don't really need to know that the CRM exists. But this CRM service will act as our point of contact to that third-party CRM, and it'll act as a translation layer between the CRM and our services. So whatever response it will get back from the CRM, it will translate into a format that the rest of our microservices will all understand, and then it can flow through, and there's no real disruption between that. So, like I said before, other services just don't need to know about it, so there's no point in enforcing it into somewhere it doesn't really need to be. And then at the end of the step function execution, let our other services know. So a sale response gets put on the event bus, and then the other services can consume that and react. So quickly on error handling in terms of the step functions, we'll have our step function catch blocks that obviously catch the error, and it'll throw that through to an internal error handler. And we've got some awesome custom middleware that was built by Andrea on the squad. Hopefully you caught her talk this morning, it was great. And that will then also capture errors, it will dispatch events. We use structured logs within those as well. Hopefully you caught me waffling on and doing my rant earlier on observability and structured logging and things like that. And dashboard visibility as well is another thing that we do like in the loyalty squad. So we've got dashboards set up to make sure that we can see if there's any order failures, if there's anything going a bit weird maybe with any services. And then in terms of testing, it's always a hot topic. So I'll sort of skip over this one fairly quickly. But we've got dedicated QA testing to make sure that all runs as it should. We've got integration tests set up, so we get it deployed up to an actual real environment that the integration tests can run against. So then we've got the confidence that we actually know that once these are getting hit, they'll actually work. So yeah, specific deployed environments, and it's a recreation of the production environment, so that gives us even more confidence that, cool, this code that we're actually writing and pushing out there might actually work when it goes to production. So a moving landscape, what does that mean? So it's an always evolving process. Working in technology, I'm sure everyone understands and knows that it's very rare for something to stay still for too long. It's the same with an order process. It's not static. That's constantly evolving. There's updates to business logic are needed, and updates to other things that might be in that order process are always looking to change. And you've got things like promotions and special weekends, things like Black Friday and Cyber Monday are huge for the Lego group in particular. So we need to be able to react and handle things like that. And the landscape outside of the loyalty platform could also change, so there could be changes outside of our own squad that we need to be aware of and need to be able to handle. Third parties can also come and go, so which then adds more credence to the fact of having this CRM service, because rather than having every microservice then needing to be updated because they all called out to this CRM, you've got one place that you might need to change to then work through that. So One little sort of example of this is some recent work we did on handling non-insider orders. So for this, we needed quite a considered approach. So we needed to be able to handle these sort of non-insider orders in the same flow as what the insider orders are currently handled in. We needed to not disturb existing functionality that was already out there and being used in a production environment that's getting hit over and over again. We also need to update any checks that are needed, so we might need some extra checks to be able to identify an insider versus a non-insider. And my good favorite, observability. We need to make sure that we can see right through A to Z, see the entire journey that this order is going on. So the order processing flow, where we have our order received, and we've got the synchronous response coming back through to the API gateway, and our order is being validated, and the event is going through to our order service, and then our good friend the task token comes in, goes and runs its checks via the CRM service to the CRM, gets its response back, goes back to the order service, and then we get our order processed event dispatch. So this is the existing order processing flow that we've got for insiders, which all is working correct and all is good. So we sort of then needed to think, okay, we've got this flow currently. How can we update this flow to handle non-insiders as well? So handle these orders from the non-insiders. So we came up with an express solution, pun intended. So what we actually decided on going with was a separate express step function. So the reason this was chosen was because it's able to run synchronously using that start sync execution that you can feed into it. So it can step in for that, where that Lambda function has that synchronous response back to the client. This would be a great fit. And we can use things like VTL, which is a templated language, to configure the request and the response. So we can then handle any inputs that are coming in and match up to what's already expected within that existing flow. And we decided that this could actually execute before the existing order process step function. So we could fit it in somewhere that could happen before that. And it'd be a short, fast execution because the logic that would be in here wouldn't really be anything massive. It's not like we'd need to be reaching out to many services or anything like that. And it'd be nice and cheap to run. So it sort of ticks all the boxes to sort of solve this sort of if problem that we were having. So this is what we actually came up with. So this is an actual screenshot of that express step function. So you can see that it's simple and effective, not really much to it. So you've got two paths, one path coming down for the insider orders, one path for the non-insider orders. And you've got one Lambda function per path that will run the dedicated logic for each one. And then from that, they'll emit an event that will then trigger that larger step function. And each one also has its own error handling, so then we can be really specific on how we handle the errors because they need to be different based on the insider or non-insider sort of status of the order. So if we take a look at the payloads quickly, it's where we can sort of work out the difference between, okay, what's an insider and what's not an insider order. We can see that there's not much that's actually different, but if you look quite close, you can see that there is a custom data object that we can look at. So that's got, so that exists on a non-insider order versus an insider order. So we'd be able to look in there, and there is a sort of VIP number field that's on the insider that's not on the non-insider. So there are definitely things there that we can actually hook into. So if we go back to this beast, is that not working? There we go. If we go back to this beast that we looked at earlier, I was a bit naughty and sort of hid something in plain sight. So this right here is how we actually implemented that entire non-insider flow. So if we sort of have a look at what updates we had to make to the order step function, wasn't actually that many. So a new choice state was added that checks the presence of a variable. So when we looked at the differences in the actual event payloads that were coming in, this is what that hooks into. It will look in there. There was no disturbance at all to the existing flow, which was one of our key things we were looking at when implementing this, because we obviously don't want to disrupt the incoming orders that we've already got. And this single choice state step allowed for this entire separate flow to actually work and exist. So we do still follow the same sort of thing as we do with the insider. We'll still run our storage first pattern, so we still store that non-insider order as we go through the flow. So now if we go back to this order processing flow again and look at how it's updated, we get our order in to our API gateway, runs to that new express step function that sends the synchronous response back so the store people can carry on about their day. And then this all looks mighty familiar. So we kept that sort of existing flow, but now we're able to handle an entirely new category of order. So what made this approach work? Work could be done in parallel, which was really, really handy when it came to development. We could actually push out changes to the step function without impacting this existing flow that was currently running. We didn't disturb that existing functionality as a result of that. So, and also like the changes made into existing Lambda functions were very minimal. At most, it may have been a couple of lines where we were checking the existence of maybe the VIP parameter or something in the new object that was introduced in the non-insider request payload. And it also gave us deployment confidence because we knew that this non-insider flow wasn't being hit yet. We were confident enough to be able to actually deploy up through the different environments and make sure that it wasn't going to impact or sort of cause any issues with anything there, which led us to this independent piece deployment. So we didn't have to build it all off in the corner and then just go, surprise, one day to the big step function and upload it all in one go. So that was really key and really handy as well. So, like I said before, this single choice step allowing for that full separate flow was something that really made this approach work too. So where are we going next in terms of our step functions and our order processing? So we know it's not perfect yet. That main order step function is huge, as I'm sure we can all attest to. And the extra traffic flow now that we're getting through to this sort of step function overall is opening up some space for more improvements, so we can look at where we can make optimizations and tweaks to things that were already there before. And we can look at extending the error handling further, so especially with the new updates that have come out recently for error handling within step functions, we can look at leveraging some of that good stuff. So the top three sort of areas we're looking to improve, making more use of the SDK integrations directly in the actual step function invocation. Look at where we could maybe remove some logic that might be being done in a Lambda function and have that done directly by a step within the actual execution. And we would also considering the possibility of splitting the insider and non-insider into separate step functions, because whether or not we want to keep them in this single mammoth sort of step function is debatable, so that's something we're looking into. And refactor to include nested express workflows. And this is mainly for things like cost optimization, because the express workflows are cheaper to run, so if we can nest some of those in and replace some of the bits that we've got in that massive step function, that would always be good to reduce any costs that we're incurring. And that's all, folks. That's all I've got for you today. You can find me on the various social platforms if you fancy that. And thank you for listening.
Perfect, thank you. Have we got any questions anyone would like to ask?
I thought I understood task tokens as being a bit like a promise, so your step function would sort of wait for a result, but then you mentioned you also use them for sort of a fan-out processing. I wondered if you could just dig deeply into there and explain where I missed what was going on.
Yeah, so the task tokens that we're using within sort of the order context doesn't really impact processing directly. It's more of acting as an event to say, go do this thing, and then allowing us to react back in the actual step function execution itself to then carry on the processing. So it's not sort of going to fan out to cause other things to sort of process too much. It's more of that, okay, you wait there while I go and check this, and then I'll return back to you, sort of thing, if that makes sense.
Yeah, that's cleared it up. Thanks.
Cool.
Any other questions? No?
How do you handle testing of these huge step functions? I've not used them personally, but having seen that they're just a huge blob of JSON, it sort of fills me with dread.
Yeah, so in terms of how we're handling the testing at the moment, we've got our dedicated QA that will run through and obviously cover it sort of that way in terms of more of a manual approach, and we've got integration tests that will run against actual deployed instances. So that's really handy. And it's an area that we're constantly looking into to sort of get better at and sort of understand more, because I know what you mean with like the massive JSON objects and things like that. And I think that's where things like CDK and the implementations that you can use with that, and how you can chunk it down really small. Yeah, so you can have the like state steps within CDK, and you could probably find a way to sort of test them maybe independently and look at something like that. But we don't have much in the way of step functions in CDK at the moment, so something that we're looking at and might be talking about in the future. Cool.
Perfect. Anyone else? No? Okay. So just a few bits of housekeeping then. We do now have some drinks upstairs. There's going to be some street food later, so please, if you'd like to stick around, please do. I think there's going to be some kind of pub quiz. Some of the sponsors are going to be giving out some prizes if you've entered any of their raffles, and someone told me there was swag, so that's exciting. But before we do that, if we could just give one last round of applause, please, to